Hey everyone, in this video, we would like to cover problem number 6 in Geometry Round B Round in PUMaC 2023, which is going to teach us a lot about like Ptolemy and like PowerPoints and Similarity and Pythagoras. So it's going to be a big deal. It's going to take a long time. So I want you to buckle up and let's just try to jump into the questions, right? So let ABC be a triangle with AB 4 and BC equals 6 and CA equals 5. Right? So if you sketch the picture, I'm not going to be I don't think I can draw the picture really nice, but hey, that becomes 4 out there. So I got A and B, and this is supposed to be B, C is supposed to be 6 out there. So that becomes C, and this becomes 5. All right, so the angle bisector of BAC. All right, so I need to draw the angle bisector. I'm not sure how that's gonna, help me, but it needs to pass through, the circumcircle of ABC. So we got to sketch the circumcircle of ABC. Oh no. All right, so there we go. We got some circumcircle of ABC, and they are meeting up at a point. If you read the question carefully, it meets up at D, and there's a point M out there. Right. And the question tells us that the perpendicular bisector of DM intersects the circle centered at M, passing through B at 2 points X and Y. What? Well, what is this question asking us? It's asking us about AX and AY. So I don't think that's going to be AX times AY. It's going to be power points because it doesn't look like power points. So probably you got to investigate this, like some quadrilateral ABMC. All right, so there must be a reason why someone gave me the problem writer actually gave me this condition out there. So like first, step 1, what do we know about BD? Like BD, that's going to be 4X. I'm just going to say 4X. And what do I know? What do I know about CD? Well, CD, that's supposed to be 5X. And if I add up these values, that becomes 9X for sure. And that turns out to be 6. So we get X equals 6 over 9. So that becomes 2/3. All right, so we got BD. Let's just try to write BD. That becomes 1/3. And we have CD. That's turning into 10 over 3. 10/3. All right, so that makes sense. The sum of those two values, the fractions, becomes 6. So it's nice. All right, so what do I know about like BM and CM? Let's just try to connect it. Let's try to connect and see what's up. Now, the angle bisector, thanks to the inscribed angles, they're actually, like the inscribing the same arcs, right? They're inscribing the same arcs, I would say. So these are the same angles, and that becomes the same angle, right? So that becomes the same angle, and we get an isosceles triangle. So let's just try to mark it as K. Let's just try to mark this as K, okay? So if I mark it as K, probably we can use the Ptolemy. So number 2, oh, wow. This question uses a lot of stuff, right? So I know that 5 times K, and I know that 4 times K, supposed to be just like 6 times AM. So 6 times AM, and that becomes 9K over 6. Equaling AM, right? So that becomes probably 1.5K, right? So we got 1.5K out of nowhere. We got those results. Let me label all these numbers up. Let me label all these numbers like 1/3, and that becomes 1/10. So we got these two decimal expressions, and I know what AM is supposed to be. Probably it's going to be a good idea for me to use PowerPoints here. And in order to use it, I would say I need to get DM first. And let's just try to look at the triangle marks that look like a ribbon-shaped. So if you look at the ribbon-shaped figures, that must be similar figures. So we know that the third step that we got to try is that 4 to 8 over 3. 4 to 8 over 3 is supposed to be CM, which is K to DM. So K to DM, for sure. All right, so what do we know about DM then? DM is supposed to be 2/3 times K. Got it. So we got 2/3 times K. So that becomes 2/3 K. And let me just switch this into 3K over 2 so that we can actually find the difference between those expressions. Let me erase this. All right, so that's K. If you subtract these two numbers out, 3K over 2 by 2K over 3, that looks like a 5K over 6, I would say. So 5K over 6, right? So 5K over 6, and I got 2K over 6. So 2K over 6 and 5K over 6. All right, so here we go. Let's just try to apply power of points. So if I use power points, that becomes a 5k over 6 times, what was it, like a 2k over 6? 2k over, was it 3 or 6? A 2k over 3. Yes, that's supposed to be 8 over 3 times 10 over 3. So that becomes 80 over 9, okay? So 10k squared divided out by 18, well, that becomes 80 divided out by 9. All right, so what can I do? Like k squared, that becomes 80 over 9 times 18 over 10. All right, so the number's getting ugly, but that's 8, and that becomes 2. Whoa, so at least we got nice value for k. So that becomes 16. So k is supposed to be 4, okay? So k is supposed to be 4, and whoa, so we got a really nice looking figure. So that becomes 4 out there, and that becomes 4 out there, okay? So now the hard part begins by graphing, I would say, the circle that is centered at M that is passing through B. So what do you know about passing through B? Can I erase this part, like 1, 2, 3? Let me erase this 1, 2, 3, because we found what k is. And I know that these are k. K is so 4 and 4 and 4, and probably 6 and 6 and 5, right? So that's an isosceles trapezoid. And let me erase all of these parts. Oh, whoopsie. It's never getting erased. Oh, there we go. Let's try to erase these things nicely. All right, so we get a picture that's lovable. And let me change the color so that there's gonna be a circle centered at M. And I would say I need to bring this picture right here. And let me erase this part so that we get a nice looking circle out there. All right, so now I can actually draw the perpendicular bisector of DM. So if I draw the perpendicular bisector of DM, that's a nice picture. It's passing through the perpendicular bisector of that perpendicular bisector. Then the new one, let's say the perpendicular bisector of XY, is definitely passing through the center M. Why? Because that's already I mean, it's been stated that way. So these are, these are isosceles triangles. So probably we can assume that AX equals AY. So I got AX equals AY for sure. So the question states that you need to get AX times AY. So probably you need to get AX squared. So what are we going to do? All right, so let's try to switch the colors. All right, so probably I need to use the power points again. Okay, so that has been cut into half. And I know that these are 8 over 3, so that must be 4/3 and 4/3, right? So that's 4. All right, so 4 plus 4/3, 4 plus 4/3. I'm using power points right there. And I'm multiplying with 4 minus 4/3, 4 minus 4/3. And that becomes something about, shall I call this like P, point P, such that that becomes XP squared. Why? Because it's going to be XP times PY, but apparently XP and PY, they're the same thing. So these are 16 minus 16 over 9. Okay. So 144 minus 16 divided out by 9. So probably 128 divided out by 9. Okay, so let me erase this. 128 divided out by 9. All right, so what do you know about XP then? XP is supposed to be 64 times 2, so 8 root 2 divided out by 3. Got it. So we got XP as 8 root 2 divided out by 3. And I know that the whole thing's supposed to be 6, but I'm only subtracting 4/3 out of it. So 8 AP squared plus XP squared. Thanks to the Pythagoras, we can actually use the Pythagoras to figure out that's going to be a right triangle. So we got AP squared plus XP squared, which is, like that. That's going to be 6 minus 4/3. So what's a 6 minus 4/3? 6 minus 4/3. I don't know, but apparently that's going to be a square, and I know what XP squared is. So, oh no, I could have just, found XP squared and be done. I didn't have to do this, all these like simplification, but we got 128 over 9 for sure. All right, so that becomes 14 over 3 squared plus 128 over 9, all right? So what's 14 squared? 196. So let me move this right here. 196 out there, and that becomes 9, and 128 over 9. And you can check that these are 324 divided out by 9. What's 324 divided out by 9? That becomes 36. Whoa, so we got 36 out there. We've been looking at AX squared, but that's AX squared. So we got 36, and that shall be the answer.